Introduction to second order derivatives. If you have a function y equals x to the power of n, the first order derivative or the gradient is the y over the x equals, bring the n down to that n, x, and take away 1 from the exponent, n minus 1. So that's the first order derivative. The second order derivative will be d 2y over dx squared equals, bring the n minus 1 down, so you got n minus 1 x, and then take away 1 from the exponent, n minus 2. Minus 1 is minus 2. Okay, let's do the third order derivative. D cube y over dx cube equals, bring the n to power minus 2 down, n into bracket n minus 1, n minus 2, x to power n minus 3. That's the third order derivative. Y equals x to the power of n. Also, that's also called f of x, which equals y. But we can also call that y dot for the first order derivative, or y dash, or y dot, or y dash, or f dash x. So that's the first order derivative. Second order derivative is y dot dot, or y dash dash, or you might call it f dash dash x. You can imagine what the third order derivative will be. Y dot dot dot, which is y dash dash dash, or f dash 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 of x. So these are the notations that you may come across. Let's try and explain what's going on here. Well, with the dy dx, it's actually you differentiating with an operator called d over dx. And that's operating on a function which is called x to the power of n. So d over dx is called an operator. And that operator is operating on y. And that's why you call it dy dx. But that operator is now going to operate on dy dx again. So we got the operator. Now this operator is operating on d over dx. As you can see, d times d is d squared. And dx times dx is dx squared. And that's still operating on y, which is x to the power of n. It's operating on it twice. And that's why you got that. You can imagine the third operation, which is d over dx, operating on that d squared over dx squared of y. D times d squared equals d cubed, operating on y, over the x cubed. So let's do an example. If y equals 5x cubed, then dy over dx will be 3 times 5, that's 15x squared, 3 minus 1. What about d squared y over dx squared, d squared y over the x squared will be, now you're operating on this now, or you could use that formula. Either way, it doesn't matter. You get the same thing. So 2 times 15, that would be 30x. 2 minus 1, x to the power 1. Well, let's try the third order derivative. So that would be d cube y over dx cube. That will be 30 times 1. So that would be 30. Then x to the power 0. 1 minus 1. But x to the power 0 equals 1. So that is just 30. It's not only y in relation to x. You could have v equals t to the power of m. So you could do the derivative of v with respect to t, and that would be m t m to the power minus 1. That's the gradient. That's the first derivative. Second derivative will be d 2v over the t squared will be equal to, well, just bring m to the power minus 1 down. So that will be m minus 1, t m minus 2. What about the third derivative? So d cube v over the t cube will be m into bracket m minus 1, m minus 2, t m minus 3 to the power n minus 3. The second order derivative is the rate of change of gradient with respect to x. Where is this actually useful is when we do the displacement is a function of time to the power of k in this case. So that's displacement equals t to the power of k. To find the velocity is change in displacement over change in time, and that will be in this case k t k to the power minus 1. And then to find the acceleration, so this one is actually velocity, so this is velocity in this case. To find the acceleration a, which is the change d2 over the s, the t squared. So this is now acceleration, which is the rate of change of velocity over time. And so that would be k minus 1 in this case, t to the power k minus 2. So this is what you could call the rate of change of velocity. So you could write this as dv over dt as well. In that case, it's k into bracket k to the power minus 1, t k to the power minus 2. So that will be the acceleration, because acceleration is rate of change of velocity over time. So that's the application there. As you can see, it's important to understand that you could use that formula straight away if you want. And if you use that formula for this one, this will be, as you can see, n is 3, and this must be 2. 3 times 2 will be 6, and 6 times 5, because there's already 5 there, so that will be 30. And then 3 minus 2, that will be 1. So yes, you could just use that straight away to find that without actually doing it this way. So you can go straight from there to there. You can go straight from there to there. Or you can do that first and then use that to do that first and then use that to do that first.